Welcome back, everyone. I hope you had a nice weekend and got caught up on some work this morning. So, before we start, here's the essential question: how can we solve systems of equations graphically? Remember, to graph something, we've learned two different ways already. We've learned the one where you get the intercepts and connect the line. We've learned the one also, this is, remember, from standard form. We've also learned the one that most people like and the one that I'm going to be using for most of the video, y equals mx plus b, where you start at the intercept and then you use the slope to go over and then across as many as you need and then connect the line. So keep those in mind. Those are review. Those are from last week. So if you need help, make sure you go to the review from last week and the week before that to catch up on that work. So our first example, option 1. There's going to be 3 options. I like calling them options because by the end of the week you're going to be able to choose what option you want to do. And this is the graphing method. So first, example 1, find the solution. So that's what we need to find. So let me underline that. Find the solution. What's our solution? The following system of equations by graphing. Systems of equation we should have gone already over in class and in the first video. And just to clear things up, let me actually scoot this over a little bit. I'm going to call this equation 1. I'm going to call this one equation 2. I'm going to do this just to keep everything organized. So I'm going to write, the first part would be, I guess, to graph it. So how do you graph this one over here? Let me write it over here, equation 1. So I want to keep it organized because work is going to get messy. So 8x minus 2y equals 10. And how do you want to graph this? Most people are probably going to use this form, y equals mx plus b. So let's keep it like that. So what do I need to do to get y by itself? Well, I need to move this 8x minus 8x to the other side. Let me rewrite that. Negative 2y equals negative 8x plus 10. Now what can I do to get the y by itself? Divided by negative 2, divided by negative 2, and divided by negative 2. Let me just scoot this up a little bit more. So then you get these negative 2 cancel out. You get y equals, what's negative 8 divided by negative 2? It's going to be positive because it's negative divided by negative, so it's positive 4x. And positive 10 divided by negative 2, it's going to be positive again. I mean, it's going to be negative because we're dividing by negative, so 10 divided by negative 2 is negative 5. So this is our first equation. Not the answer though, it's just the equation. So let me go ahead and graph it. Let me go down to negative 5. 1, 2, 3, 4, 5. There's our first point. It's negative 5. Don't forget to label your axis. Now I have to go up 4 and over 1. So I go 1, 2, 3, 4, over 1, put a point. 1, 2, 3, 4, put a point. 1, 2, 3, 4, put a point. I could keep going, but that should be good enough. Let me do my best attempt and try connecting these lines. That wasn't that bad. So that's our first equation, equation 1. Second one, we could do the exact same thing. Again, you could use standard form, but most people like y equals mx plus b, so let's do that. So 3x plus y equals 2. This is going to be a lot easier. What do you need to do to get y by itself? Subtract 3x. Get these 3x's to the other side of the fence. So y equals negative 3x plus 2. And here's our second equation. That was a lot easier, wasn't it? So again, you go to the intercept, which is 2. 1, 2. And you go down 3 and over 1 because it's negative 3. So your rise is going to be negative 3. So 1, 2, 3, and over 1. Oh my god, something just happened. 2, 3, over 1. 1, 2, 3, over 1. What just happened here? The lines just crashed. They just crashed. Where did they crash? Right here. What does this mean? This is what we're looking for. This is our solution. Remember, a solution to lines, graphically, it means where they intercept. What does this mean? This is up to you to figure out in a discussion, so you will have to tell me. But let's take a closer look at this. Where do they intercept? Well, this point right here is 1 and negative 1. So that's our solution. But As good mathematicians, we always got to check our work. So let's make sure that 1, -1, we have our solution over here. Let's just make sure that this is always correct. You always want to double check your work. In math, there should be no reason why you got the wrong answer, because you can always double check your work. So let's write the first equation. Let me use this one actually right here. Y equals 4x minus 5. Let's plug those numbers in. We get -1. This is x, this is y. Equals 4 times 1 minus 5. Let's put this down. -1 equals 4 minus 5. -1 equals -1. So that's correct. But we have two equations. Remember, we got to check for both of them. Y equals -3x plus 2. Let me plug those in. Again, -1 equals -3 times 1 plus 2. -1 equals -3 plus 2. What's -3 plus 2 is -1. -1 equals -1. So that is correct again. Hooray, we're done. So again, your solution would be, let me just circle this in black, 1, -1, and that's the solution for the first example. Now after this, I'm going to show you a different example. It's going to have similar things, but at the end of it, it's also going to be the summary. So make sure you watch that video too.